Hello everyone, this is Mr. Appel, and now I'm going to show you a shortcut for using your understanding of some transformations of parent functions and graphing them a little more quickly than graphing in phases. So if you see a function like this one here, f of x equals 3 times the absolute value, x minus 1 minus the 5, you should first recognize that that's the absolute value parent function. So the parent function is the absolute value of x. You should be able to generate a quick table of values. You should know that parent function now quickly and easily right now, that negative 2, negative 1, 0, 1, and 2, and that the y values are 2, 1, 0, 1, and 2. So you should have that kind of familiarity with the parent function. And now what we're going to do is identify the transformations. So in here, that x minus 1 means that it's going to go right 1. This 3 is a stretch by a factor of 3. That's a vertical stretch. And then this minus 5 is a translation down 5. So left and right is affecting the x value. Stretch, compress, or in this case stretch, and also up or down, in this case down, are all affecting the y value. Those are up and down changes. So the x change was right 1. So if you move right 1 on the graph, each x value increases by 1. So my left column is just going to be x with 1 added to it to account for going right 1. My y value is a vertical stretch by 3, which is multiplying the original y value by 3. And then down 5 is subtracting 5 from the y value. So now all I'm going to do is take my original x's and y's over here and apply those transformations. And so each x value I'm going to add 1. So negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. And then 1, and then 2, and then 3. So again, we just added 1 to each x value. And then the y values are going to get multiplied by 3, and then 5 subtracted from it. So the first y value here is 2. So I'm going to do 3 times 2 is 6, minus 5 is 1. And if you can do this arithmetic in your head, this process goes really fast. So 3 times 1 is 3. 3 minus 5 is negative 2. 3 times 0 is 0. 0 minus 5 is negative 5. 3 times 1, and again, we're looking at the original y values, the parent function y values. So 3 times that 1 is 3, minus 5 is negative 2. And 3 times 2 is 6, minus 5 is 1. So that quickly, instead of having to go through each phase separately, we're kind of doing them all together in one shot. That's what's happening in this table. And then you'll see when we graph it, it's going to have everything we want. So negative 1, 1 is right there, 0, negative 2, 1, negative 5, 2, negative 2, and 3, 1. And if we go ahead and sketch that, we still have our familiar V shape. We notice that it's much skinnier, which that stretch by a factor of 3 would indicate, and it's been translated right 1 unit and 5 down. So you see the vertex there is at 1, negative 5, because the whole graph is moved right 1 and down 5. And that is what we'd be looking for. So again, I want to see the original table, the parent function table, identifying the transformations, and then using those transformations to describe the rule of what happens to the x and y values, and then go ahead and apply that to the x's and y's, and then you can go ahead and graph. And again, a lot quicker and easier than graphing each phase separately. Hope this is helpful. Thanks.